Okay, so today we're going to finish up section 1's notes. Let's go ahead and we're going to do some more practice here of finding the vertex, axis of symmetry, x-intercept, y-intercept, and then graph it. Now, when we want to get it into, on the quiz next week, you are going to have to complete the square. So you will have to demonstrate that and get it into vertex form. Now, one thing to keep in mind, you can use that other technique I told you, the negative b over 2 times a, to double check your vertex if you ever have time to do that. That's another way that you could do this. But I'm going to go ahead and do the completing the square on this one because that's what's going to be required on the quiz next week. So first thing I'm going to do is move the constant away. I'm not moving it to the other side of the equal sign. I'm just going to move it out. So also you need to check that the number in front of x squared is a 1, and it is. So I'm going to do x squared minus 4x, leave the blank space here, and then shift over the constant. Now my next step is to take the b term, divide it by 2, and square it. So negative 4 divided by 2 is negative 2. Negative 2 squared is 4. Now, normally I would be adding 4 to both sides, but since I didn't move it to the other side of the equal sign, I'm going to subtract 4. But in here, remember, I always put in what it was before I squared it, just to make my factoring of that trinomial easier. So now I have f of x. I'm going to factor the trinomial into x minus 2 squared. I have to combine these terms, and then now that gives me my k. So my h is here, and this is my k. So my vertex is the order pair positive 2 and negative 1. For the y-intercept, I'm going to go back to my original, because remember your y-intercept is always this c value. So my y-intercept as a coordinate is the order pair 0, 3. However, for the x-intercepts, we've got to work for it. Now, if you want to use the original, actually the original would probably be faster than doing the square root method. I could actually factor it. Now, so whenever you want to find your x-intercepts, remember you're setting y equal to 0. Now, what I can either choose to do is use my original f of x, x squared minus 4x plus 3, or I can use my newly found vertex form and solve either one. It doesn't matter. It's up to you. So I can show you both ways. So again, I'm setting y equal to 0, which is really the f of x. So I'm going to put a 0 here. I'm going to factor this. It's factorable. If it wasn't factorable and you use the original, then you'd have to use quadratic formula or completing the square. But because it is factorable, it'll be x minus 3, x minus 1, set each factor equal to 0. This is one method you could use to find the x-intercepts. I get x equals 3, add 1, x equals 1. So my x-intercepts, by using the original, would be the order pair 3, 0, 1, 0. Now, if you use, usually it's easier to use the vertex form, or what they call the standard form. Plug it in, do the square root method by adding 1. 1 equals x minus 2 squared. Square root both sides. I get plus and minus 1 is equal to x minus 2. Add the 2. 2 plus and minus 1 equals x. Remember, when there's no radical, you actually have to do the problem. So 2 minus 1, and then 2 plus 1. This will give me 1. This will give me 3. And then I end up getting the same exact x-intercepts. So you can do either method, either using the original or using the newly found standard form to find your x-intercepts. So now that I found, again, on the quiz next week, you will be asked to find the vertex or the standard form, the vertex, the y-intercept, the x-intercepts, and the axis of symmetry. And again, the axis of symmetry is always an equation. It's x equals, and it's going to be the x of the vertex or your h value. And in this case, it's x equals 2. Okay, if you just tell me the axis of symmetry is 2, you will get it wrong on the quiz next week. So just be careful. So now let me go ahead and graph these pieces on my coordinate plane here. I'm going to graph my vertex first. It's the order pair 2, -1. Then I'm going to graph my y-intercept, which was 0, 3. And now if you just want to use your axis of symmetry, which would be this imaginary line that goes through the vertex, we can use, see that it's like a reflection 2 units away. So then put 2 units away here, and then you can get your third point, and then you can graph it. Or you could have used the x-intercepts you found. Remember, they were 1, 0, and 3, 0. So you could have also used those. But either way, I missed it a little. And that would be your graph. Let's try number 9. We're going to do the same thing. However, this one has a number in front, so it's a little bit more challenging. All right, so again, same things, finding vertex, axis of symmetry, x-intercept, y-intercept, and graph it. I'm going to go ahead and when I'm going to do completing the square, I got to get rid of this 2. Now, I'm not going to divide the constant by 2. I'm going to move it out first. So I'm only going to divide out the 2 from my 2 variable terms. So I'll put a 2 here. This becomes x squared. This becomes 4x. Leave the blank space, and then put the +7. Now I take the b term, divide it by 2. So my b term is 4 now. Divide by 2 and square it, and I get 4. Now, when I go to put in my other number that I'm going to be putting here, I have to take into consideration this 2, and I should be subtracting 4, but I have to multiply it by the 2 I factored out. So really what I'm subtracting here is 2 times -4, and it'll be a -8. Now, also in here, I am putting in this, my 2 squared. So now I have 2. I can factor that thing, and then I combine these guys. I'll have my function in standard form. I can pull out my vertex. My vertex is the order pair, and this is H. This is K. And again, it's backwards of what you think for the H. So it's -2, -1. My y-intercept, remember I go back to the beginning, and that's the +7. So that'll be the order pair 0, 7. Let me go ahead and put my axis of symmetry here as well. It's right up above here. It's the H of the vertex. X equals -2. And now I have to work for the x-intercepts. So for your x-intercepts, for this one, I'm going to go ahead and it's going to have a radical. So if I were to have tried to use the original, I would either have to do quadratic formula or completing the square. So I'm just going to use my standard form. So again, remember, set y equal to 0. So I'm going to be doing 0 equals 2 times x plus 2 squared minus 1. I'm using the standard form here. First thing I want to do is isolate my squared term. So I'm going to add 1. And then I have to divide by 2. And I get 1/2 is equal to x plus 2 squared. I have to square root it. So I get plus and minus 1 over the square root of 2, because the square root of 1 is 1. Now I need to rationalize this. So let me go ahead and do this over to the side. Rationalize that plus and minus 1/2, and this will become plus and minus square root 2 over 2. And then now I can subtract the 2. So my x-intercepts are located at -2 plus or minus square root 2 over 2. So as coordinates, it'll be -2 minus square root 2 over 2, comma 0, and -2 plus square root 2 over 2, comma 0. Now, you're not going to have to graph the x-intercepts, but you will have to list them on the line. So now let's go ahead and graph. I can get away with just graphing my y-intercept and my vertex and use my axis of symmetry to get the third point. So if I come back up here, I'm going to graph my vertex, which was the order pair -2, -1. My y-intercept was 0, 7. So it's way up there. I'm going to draw in my axis of symmetry, because to get my third point, to get the left side of my parabola, see how this point is 2 spaces away? I could go 2 spaces away over here. It's like a reflection. And now I can graph my parabola. So I can connect them. And there's your parabola. Now, you could also approximate the location of your x-intercepts if you wanted to, but honestly, just graph your vertex, graph the y-intercept, use the line of symmetry. If you did approximate these x-intercepts, we could say that the square root of 2 is probably about 1.4. So if we did -2 minus root 2 over 2, that would be -2 minus 1.4 over 2. And we could actually approximate that to be about -3.4 over 2. And then we could divide that just to see if we're, kind of close. This would be about -1.7, comma 0. And then I could do the same thing on the other one. -2 plus 1.4 over 2. 1.4 divided by 2. This would be -2 plus 0.7. And then I would get -1.3, comma 0. And if you notice when I graph these, they were pretty close. This was about 1.3. And then this was about -1.3, comma 0. And then -1.7, comma 0. Or what was it, 2.7? What did I get? -1.7. So that is number 9. Next, we're going to finding the standard form of a quadratic function. So you're going to be given a vertex and you're going to be given a point. We're going to have to solve for A and then put everything back in again. So let's go ahead and try that. So we're given a vertex. Remember, this is H, this is K. Remember, the vertex or the standard form is f of x is equal to A times x minus h squared plus k. So far I already have an h and a k. And then my ordered pair, this is going to be my x and my y. So let's go ahead and plug these four numbers, and we're going to solve for a first. So we're going to plug in f of x, which is really y equals, remember this is really your y. So I'm going to do -6 equals a times 3 minus 1 squared plus 2. I'm going to simplify the parentheses. This will become 2 squared. Then it becomes 4a plus 2. Then I can move the 2 over. I get -8 equals 4a. I'm going to divide by 4, and a equals -2. Now what I'm going to do is go back to my equation. I'm going to fill in a, I'm going to fill in h, and I'm going to fill in k. So again, we're going to fill in f of x, my newly found a, which is -2. My h was given to me at the beginning. It's -1. And then my k is +2. And this is squared. So you're going to solve for a. And then once you get a, go back and all you're filling in is the a, the h, and the k. Let's try the next one. So again, it's f of x. We're filling in f of x equals a, x minus h plus k. So again, f of x is the y. So my y is 5. I don't know a. My h is -4. So really what I'm going to put in here is a negative is a +4. And then the k was 11. And I also have to replace the x. Let me go back there. I also have my x value. So my x is -6. So now I'm going to simplify the parentheses. I get -2 squared. So -2 squared is +4. So 4a plus 11. Subtract 11. -6 equals 4a. Divide by 4. A equals -6 over 4, which simplifies to -3 over 2. So now I'm going to take my newly found a and then my original h and k and plug it back in. So f of x, put in your a value, leave the x, put in the h, and put in the k. And you're done. So we're not using the calculator yet, but if there is time, I will show you how to use the trace feature. So again, we're not going to do the graphing utility yet. This is the same problem that I already did. This was example, I think it was 8 or 9. It was number 8. So I'm going to show you how to use the graphing utility if there's time at the end, but we will definitely use our graphing calculators for the polynomial graphs. So here it says writing a quadratic in standard form using completing the square. And this is really all that I've been doing all along. So this is actually the steps, step by step of what to do. However, I've already shown you how to do this in the prior examples. So let's just do some more now. So here it says to put the equation into standard form. Again, some books or maybe on an SAT, you might see it represented as vertex form. And then it says to find, again, the same stuff, the vertex, y-intercept, x-intercept, axis of symmetry. So let's go ahead and follow the steps. So again, this time instead of f of x, they have y equals, but it's still the same thing. So y equals nothing to divide out. So I'm just going to shift over my constant. take the b term, divide it by 2, and square it. So negative 3 squared, and it gives me 9. So again, I like to put it in here as plus negative 3 squared. So when I factor it, it's easier. Now remember, if we would have moved the constant to the other side, we would be adding 9 to that y side. But instead, I'm just going to subtract the 9. So then I'm going to factor the trinomial, x minus 3 squared, and then I combine these two terms, and that gives me negative 12. I now have it in the standard form. This is h, this is k. So my vertex is located at 3, negative 12. Remember, your axis of symmetry is an equation. It's always x equals, and it's the h of the vertex. Then for my y-intercept, again, I can go back to the original, and it's just that c value. So it's going to be 0, negative 3. And now for the x-intercepts, I can't factor that original one. So in order to find the x-intercepts, I would either have to do quadratic formula or completing the square. Since I've already completed the square, I'm going to use my standard form and plug in a 0 for y. So for the x-intercepts, I'm going to set y equal to 0. So 0 equals x minus 3 squared minus 12. Move the 12. 12 equals x minus 3 squared. Use the square root method. I need to put 12 in simplest radical form. So I could do 4 times 3. So it becomes 2 radical 3 equals x minus 3. And now I'll move the 3. And 3 plus or minus 2 square root 3 equals x. So my x-intercepts are the ordered pair 3 minus 2 radical 3, comma 0, and 3 plus 2 radical 3, comma 0. It did not ask me to graph it. We could graph it. Again, I'm just going to use, if I were to graph this, I would just use these two and then use the axis of symmetry. Again, that way you don't have to worry about what is the square root of 3. So if we just do a quick rough graph here, it's going to be kind of low because my vertex is at negative 12. So 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So my vertex is located right here, and my y-intercept was located at 0, negative 3. Again, I could draw in my axis of symmetry, and we can see that y-intercept is 3 spaces away to the left. So I could go 3 spaces away over here, and now I can connect my points. Just by graphing the vertex and the y-intercept and using the axis of symmetry like a line of symmetry and reflect it. Let's try another example. Same thing, just more practice of the same. So next one, again, put it in standard form, nothing to divide out. So y equals x squared minus 4x, leave a blank space, and move the constant. Take your b term, divide it by 2, and square it. Negative 2 squared, and I get a 4. So I'm going to be subtracting 4 backwards of what you would think, and then in here I always put the negative 2 squared. I factor it to x minus 2 squared. I add these two, and I get minus 11. My vertex is located, again, this is your h and k. My vertex is positive 2, negative 11. I don't know what that blue dot is. Okay, and then my axis of symmetry is again always an equation, x equals 2. For my y-intercept, go back to your original. It's sitting right here at the -7. And now for the x-axis or x-intercepts, I need to set y equal to 0. If I tried to use the original, it cannot be factored, so I'd have to do completing the square or quadratic formula. I've already completed the square, so let me take that standard form, set it equal to 0, add the 11, x minus 2 squared, apply the square root method, plus and minus the square root of 11 equals x minus 2, add 2, 2 plus or minus the square root of 11 equals x. So my x-intercepts are 2 minus the square root of 11, comma 0, and 2 plus the square root of 11, comma 0. And again, if I want to do a quick little rough draft of my equation, again, it's way down here at the bottom because I've got a vertex at -11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and then +2. So my vertex is right here. My y-intercept is at -7. And again, if you draw in your axis of symmetry, you can see that it's 2 spaces away. So you can come 2 spaces away over here, and then you can connect your points. So connect them. Just come on up. And then that would be the graph. If you were to approximate the square root of 11, I would say it's about 3.3. So if you wanted to approximate your x-intercepts, 2 minus 3.3, comma 0, 2 plus 3.3, comma 0, this would give me 5.3, comma 0, and -1.3. So I went in between. I went, I guess, a little off. 1, 2, 3, 4. And then you could have said this was about 5. So it's about right. Let's try another one. Now, let me show you a way that you could double check your answer on this next one, just to give you a little heads up, I guess. Or actually, I'll do it on the last one because it actually has an A value. This one's the same thing. Just do y equals x squared minus 5x, leave a blank space, move the 4, take the b term, divide it by 2 and square it. I'm going to leave it a fraction. It'll become 25 over 4. And so here, this one's a little bit more work because I'm adding, or I'm subtracting 25 over 4, but in here, I'm going to put it in as the -5 over 2 squared. So when I go to factor this, x minus 5 over 2 squared, I have to find a common denominator for these guys. So I could do -4 over 1, 25 over 4, change this to 16 over 4, and this becomes -41 over 4. So my vertex is located at 5 over 2 and -41 over 4. My axis of symmetry is x equals 5 over 2. Now, if you wanted to graph this, you could have also said it's 2.5 or 2.5. Same thing for the vertex, since we're graphing it. I'm going to make this 2.5 and then 41 divided by 4 is 10 1/4. Because I got to graph that point if I were graphing it. If I'm just listing it, I could leave it improper. Now, for my y-intercept, I can go back to the original, and it's 0, -4. For my x-intercept, that can't be factored, so I would have to do completing the square quadratic formula. So what I'll do here is take the standard form, the y equals x minus 5/2 squared, set y equal to 0. So then now I'm going to add the 41/4 to both sides. And I'm ending up with 41/4 equals x minus 5/2 squared. Apply the square root method. I get the square root of 41/2, plus or minus. Then I move the 5/2 over. Five over 2 plus or minus square root 41/2 equals x. If you want to combine it into one fraction, you can. So the x-intercepts would be 5 plus or minus root 41/2, comma 0, and again, pull them apart. And then 5 plus 41/2, comma 0. So 16, again, we cannot leave this 2 in front. I got to get rid of it first. So I'm going to factor out. I get x squared minus 3/2x, leave the blank space, and then move the constant out. Take the b term, divide it by 2, which is really multiply by 1/2, and then square that. So then this becomes -3/4 squared, which is 9/16. Now, I have to take into consideration the 2 that I factored out, and I would be subtracting 9/16. I could simplify diagonally here, make this a 1, make this an 8. So what I'm subtracting here is going to be 9/8. In here, I'm going to put the 3/4 squared. So now I factor it. X minus 3/4 squared, and then I have to combine this. I'm going to make my whole number 8/8, and when I subtract it, I get 1/8. So then now what we can do, this is our standard form. So my vertex is located at 3/4 and -1/8. My axis of symmetry is x equals 3/4. My y-intercept, go back to the beginning, it's 0, 1. And now to get the x-intercept, I'm going to use the standard form, and I'm going to set it equal to 0. Add the 1/8. 1/8 equals 2 times x minus 3/4 squared. Divide by 2. And when I do this, 1/8 divided by 2, flip, change it, and it becomes 1/16. Square root both sides. This becomes plus and minus 1/4. Add the 3/4. I actually have to do the math here because the radical's totally gone. So 3/4 plus and minus 1/4 equals x. So I would get 3/4 minus 1/4 and 3/4 plus 1/4. This is going to give me 2/4, which is 1/2. This will give me 4/4, which is 1 whole. So my x-intercepts are at 1/2, 1, and 1, 0. So these are my x-intercepts. Now, one thing you can do if you're ever uncertain about the vertex form or the standard form that you found here, you could always take your original problem. This is the cheating way. Minus 3x plus 1. I taught you before that you could find your vertex by doing negative b over 2a. So you would get 3 over 2 times 2, 3 over 4. This gives you the x of your vertex. Then what you can do is take this x, plug it in to both of the x's to get the y. So then now what we would do is y equals 2 times 3/4 squared. Multiply that. So then this becomes 2 over 1 times 9 over 16 minus 9 over 4 plus 1. I can simplify this, 1, 8. So I get 9/8 minus 9/4 plus 1. So now I need to find a common denominator. It's going to be 8. I'm going to change 9 over 4 into 18 over 8, and I'm going to change the whole number 1 into 8 over 8. So then now what I can do is subtract. I get negative 9 over 8 plus 8 over 8. And then when I subtract, I get the negative 1/8. So my vertex is, this is the y, this was the x. So my vertex was 3/4, negative 1/8. The same vertex I got when I did completing the square. So if you're ever uncertain about your vertex, you can do that. Now remember, this is h, this is k. This a from the beginning is the same a that's the a in the vertex in the standard form. So this number here in your standard form, actually here was the standard. This 2 and this 2 are always the same. That's your a value. So you could always take your h and k, and if it asks you to write it in standard form, take the original a, and then x minus 3/4 squared minus the k, or plus the k, but in this case it was negative. And then the last example is still the same thing. We have to get rid of that negative sign in front. So I need to divide -1 or factor out a -1. X squared minus 3x, leave a blank space, move the constant, take the b term, divide it by 2 and square it. This gives me 9 over 4. Now you have to take into consideration the -1, and we would be subtracting 9 over 4, so we're really adding it. And then in here I put the -3 over 2 squared. I factor it. I leave that negative sign there. So then it becomes x minus 3 over 2 squared. I can combine these. My common denominator is 4. So I'm really doing -16 over 4 plus 9 over 4, which gives me 7 over 4 negative. So that's my vertex form, or my standard form. So my vertex is located at 3 over 2 and -7 over 4. So if I'm graphing this, it would be 1.5 and then -1 and 3/4. My axis of symmetry is x equals 3 over 2. My y-intercept, go back to the beginning, it's just the -0, -4. However, for the x-intercepts, again, we're going to take this, set it equal to 0, negative x minus 3 over 2 squared minus 7 over 4. Step is to isolate the square term. So I first add, and then I'm going to divide. So 7 over 4 equals negative x minus 3 over 2. Divide both sides by negative 1. So negative 7 over 4 equals x minus 3 over 2. Square root it. And I'm going to get an imaginary here. So plus or minus I radical 7 over 2, x minus 3 over 2. I'm going to add 3 over 2. X equals 3 over 2 plus or minus I radical 7 over 2 would be your x-intercepts. You could combine it with one denominator. So plus or minus, and then you could pull it apart. Now, you will not have to graph an imaginary, but you will have to list it on the line. So my two x-intercepts would be 3 minus I radical 7 over 2, comma 0, and 3 plus I radical 7 over 2. Those would be your two x-intercepts. So again, it's not real. So if they ask you for only real answers, you would say none. Okay. But if they ask you to list all x-intercepts, you would list the imaginary. So if it only asks for real solutions, you would say that there are none. But if it asks to list them, and if it says list all solutions, then you would list the imaginary. So we will not be graphing I in this course. That would be something that you'll do later on in either pre-calculus or calculus. So that is it. I know it was kind of long, but again, it was just a bunch of repetitive practice. So your homework is the 3.1b.